All right, everybody, here is the second lesson of polynomials, long division, and synthetic division. We're going to start with something we haven't done for quite a while. It is long division by hand. So we're going to take 327 and we're going to divide it by 12. I'm just trying to recap what your thought process should be. You ask yourself, does 12 go into 3? And you say no. 12 goes into 32 twice. And so once you have that number on top, you multiply it by the 12 to get 24, and then you are subtracting these values. You get an answer of 8, and then this 7 drops straight down. You have 87, and then you're asking yourself, how many times does 12 go into 87? It goes 7 times. So once this number's on top again, you multiply the 7 times 12, and you have your 84, and you subtract one more time, and you have a remainder of 3. Okay, now we're going to take a look at what a division statement is for this as well. One of the division statements is starting with the 327 and then asking yourself, how do you get that answer? And what you do is you take your 12 and you multiply it by the answer you got, which was 27, and then you need to add on the remainder, so you have that plus 3. Your other division statement, the other form of the division statement, is a restatement of the question. So you take your 327 and you divide it by 12, and the answer you got when you did that was 27, and then you had a remainder. The remainder was 3, and that remainder is always over what you were dividing by. So it is 27 plus 3 over 12. Okay, now where I'm going with this is long division of polynomials. So we're going to take this question here, this x plus 3, and we are going to divide it into x squared plus 7x plus 17. The thought process is you look at your first terms only, and you ask yourself, x times what gives you x squared? And of course, you need an x. So that goes on top, and then once you have this value on top, you multiply it by the x plus 3, and you will get x squared plus 3x, and then you subtract. So you have your 7x minus 3x is 4x, and then remember this 17 gets dropped down. So you have 4x plus 17, and then you repeat the process. So you look at your first terms, you look at your x and your 4x, and you say x times what gives you 4x, and you know that you need to multiply it by 4. And so then once you have that value on top, you multiply it by the x plus 3, and you get 4x plus 12. And then you subtract. 17 minus 12 is 5. And remember, this value on the end is your remainder. Okay. Now we'll just do one more little example here of long division. We're going to take our x minus 2, and we're going to divide it into this long polynomial here. I don't know if you noticed or not, but when you look at this polynomial, the order has been changed around. So your first step is to write it in descending order of the exponent. So it's 5x to the third has to go first. Then you're going to write down your x squared term, and then your x term, and then your negative 9 here. And you just keep repeating the same process we had before. Look at your first terms. X times what gives you 5x to the third? So you are missing a 5 and an x squared, so it's 5x squared. And then you multiply that out here. So you're going to get 5x to the third minus 10x squared. And then I'm going to tell you that this is the spot here that is the most common source of error. I'm going to do it actually off to the side. You're going to take your negative 13x squared, and what you have to do is you have to subtract your negative 10x squared. So please take a look at that. You will see the double negative becomes a positive, and you're doing negative 13 plus 10, which gives you the negative 3. And then you're dropping your term down, plus 10x, and then again you're looking at your first terms. X times what gives you negative 3x squared? So you need the negative 3, and you need another x, and so then you multiply again. You'll get negative 3x squared, you're going to get positive 6x, and then this one's your subtraction. 10 minus 6 is 4, and then you drop down your 9, and we repeat the process one more time. X times 4 will give you 4x, so we will have the 4x minus 8, and again, be very careful with this. It is negative 9, I'm doing it off to the side here, negative 9 subtract negative 8 is like saying negative 9 plus 8, which gives you a remainder of negative 1. Alright, so this is quite a lengthy process here. Turning the page, scrolling down. And I'm going to show you something that will speed up this process dramatically. It's called synthetic division. So what we're going to do, we're going to start out with what I call a shelf. And this is going to be something that you have not seen before. On top of the shelf here, we are going to write the coefficients of the first polynomial. We're going to write down just the coefficients. So we're going to write down a 1, a positive 7, a positive 14, and a 9. And off to the side, you're going to put the opposite of this value right here. So if it's x plus 1, we're going to put negative 1 off to the side. Okay, and just bear with me for a while. This does have a purpose. The first step in synthetic division is this first constant drops straight down, so the 1 drops straight down to become a 1 there. We still need to find these three values here, and what we're going to do is we're going to involve this number off to the side. So we're going to take this number off to the side and we're going to multiply it times the 1. So we're going to go negative 1 times 1, which is negative 1, and then we're going to add the value above it. So it's going to be negative 1 plus 7, which is positive 6. And then we're going to just keep repeating that same process, always involving the number off to the side. So it's going to be negative 1 times 6 is negative 6, plus 14, which is positive 8. And then we're going to repeat it one more time. Negative 1 times 8 is negative 8, plus 9 is positive 1. Okay. Now, the idea is this is actually the answer to this division question. These three values here represent coefficients. They are the coefficients of x squared and x, and then the constant. This is 1x squared plus 6x plus 8. That is the answer to this division question, and the number on the end represents the remainder, and so that will have a remainder of 1. Okay. Now, if we were to do this exact same question here using long division, trust me, we're going to get the same answer. If you want to do this on your own for practice, go ahead, but this will be the answer. Okay, so we're going to do a couple more examples of synthetic division. We're going to take and draw a shelf. We're going to write down our coefficients on the top, a 2, 3, a negative 4, and a 15. And off to the side, we're going to write the opposite value here, which is going to be negative 3. Okay, reminder of the steps. The first value drops straight down, and then we're going to always involve the number off to the side. So it's going to be negative 3 times 2 is negative 6, and then we're going to add the 3, and we're going to get negative 3. Negative 3 times negative 3 is 9. Adding the negative 4 gives us a value of 5. And then negative 3 times 5, negative 15 plus 15 is 0. So our answer to this question, these are the coefficients, so it's going to be 2x squared minus 3x plus 5. A remainder of 0 we don't need to write in. What this means is that this divides evenly into the original polynomial because there's no remainder. And our last example, if you look at this first polynomial right here, hopefully you will notice something is different about it. And what is different is that it's missing one of the terms. It's missing an x squared term. When you put these coefficients on the top of your shelf, that x squared term has to be represented. So this is your x to the third term, 1x to the third. There is no x squared term, so it's like a 0x squared. And then there's a negative 10, and then there is a 6. Off to the side is always the opposite value here, so we have a negative 4. A reminder, this value drops straight down. It's a 1. Negative 4 and 0 is negative 4. Positive 16 and negative 10 is a 6. And negative 24 and 6 is negative 18. So remember, these are the coefficients of your answer, which would be x squared minus 4x plus 6. and this number here represents your remainder. All right, hopefully this has cleared things up.